An introduction to circles. Let's start by looking at Pythagoras' theorem in this right-angled triangle. So the longest side is r, so r squared is equal to x squared plus y squared. The equation of a circle centered on the origin. This circle has its center at the origin. xy is just some general point on the circumference of the circle. The distance between the center of the circle, that's the origin, and this point xy is equal to the radius of the circle. And we can draw a right-angled triangle using the point xy. So if we come straight down, that makes a right angle right there. And so from here, we can say that x squared plus y squared is equal to r squared. That's certainly true in the right angle triangle, and that's true for this point being anywhere on the circle. So for instance, if xy was a point here on the circle, you've still got a right angle triangle. So this relationship between xy and the radius r holds for any point on the circumference of the circle. So this is the general equation of a circle that's centered on the origin. If the circle is centered at a point other than the origin, then this equation does not apply. This circle here has a radius that's equal to 4. The distance between the center and the circumference is 4 units. So we can say that, again, from the equation of the circle, r squared equals x squared. So x squared plus y squared is equal to the radius squared. The radius is 4. So x squared plus y squared is equal to 4 squared, which is 16. That's the equation for that circle. This circle has a radius of 5 units. A radius is never negative. It has to be a positive value. It measures the length of something, and length is never negative. So that's 5 units here. So x squared plus y squared is equal to r squared. The radius is 5, so the radius squared is 25. So that's the equation for this circle. This circle here has this radius. So it's just drawing the right-angled triangle there. So in the right-angled triangle, this side here is the y-coordinate. So this side is represented by 8 units. This side here by 6 units. So the longest side there, using Pythagoras' theorem, will be 6 squared plus 8 squared. And so far that gives 36 plus 64, which is 100. So that's the radius squared. Okay, x squared plus y squared equals r squared. That's the radius squared. So the equation of the circle is x squared plus y squared is equal to the radius squared is equal to 100. The equation of a circle not centered on the origin. This circle is centered at the point with coordinates a, b. So some general point. It could be down here, it could be here, anywhere. xy represents the coordinates of some point on the circumference, anywhere on the circumference, and r is the radius. So from the point, if I just come straight down up to around here, and then go along here horizontally, because that's vertical, that's horizontal, we have a right angle here. So we can use Pythagoras' theorem Now the question is, how long are these two sides? Well, this side here, the length is just the difference in the x coordinates. So we've got a, we've got x. So this side here is just x minus a. This side here is just the difference in the y coordinates, so y minus b, y minus b. So the radius squared, so this side, the longest side squared, is equal to the sum of the squares of the two shorter sides, so that's equal to x minus a squared plus y minus b squared. So the equation of a circle that's centered on the point with coordinates AB with radius r is this. Things to pay particular attention to here are if you have a for the x coordinate, in the equation it says x minus a, opposite signs. If the y coordinate here is b, then in the equation here it says minus b, again opposite signs. So if you had a circle that was centered at the point 3, 2 and had a radius equal to 5, then the equation of the circle would be based on the x coordinate there first. That's positive, so this would be x minus 3, that's plus 3, that's minus 3, squared plus, that's always a plus in the middle, y, that's positive, this would have the opposite sign, is equal to the radius squared, or 25. If you had a circle that was centered at the point minus 5, 3, and had a radius which was equal to the square root of 10, then you would have x, and it's the opposite sign. That's a minus 5, so that would be plus 5 squared. That's always a plus in the middle. Then you've got y, that's 3, so the opposite sign to that is minus 3 squared is equal to the radius squared. If that's what r is equal to, then r squared is equal to 10. That's equal to 10. You have this equation for some circle. What are the coordinates for the center? Okay, now we need the x and y coordinate, but the signs are opposite. That says minus 2, so the x coordinate would be 2. That says minus 5, so the y coordinate will be 5. The radius squared is this value here. So the radius will be the square root of, which is 5. Now this circle here looks a bit unusual. The equation doesn't have anything for y there, so you can think of it like this. So it's like there's a 0 there. Won't make any difference whether you put a plus or a minus there. So the center of the circle, that's a plus 4, so that goes like this, minus 4, that's a 0, that's still going to be 0. So the thing to remember here is if there's no number, like if that 4 was missing there, then the x coordinate would have been 0. This y term here, it doesn't have any number with it in brackets like this one here does. So the y value there is 0. The radius squared is equal to 50. So r is equal to the square root of 50. That can be simplified. So we can write it like this. Root 25 is 5, and root 2 you can't simplify. So the radius is 5 root 2. And these are the coordinates for the centre of the circle.